Hello, welcome back to More Fun Fixing It. I've got a couple of Commodore 64's on the bench today. These were last seen in a recent triage episode, and this one has, in diagnostics, it says it's got a bad BASIC ROM, and I also replaced the fuse in this one. And this one over here says kernel bad, so that came up in diagnostics in that episode as well. So I thought I'd do both of these at the same time. Now, the keyboard out of this one is from a C64C, which is waiting for repair over there. Oops. But this one has a hole in the side, as Paul says, a peephole in the side here where someone's fitted a reset switch. And they've also soldered the reset wires. So I'm going to need to remove that. But also, with this one being the BASIC ROM, I need to take that BASIC ROM out and put a new one in. Or put a socket in and then put a new one in. But we're going to do something slightly different. So we're going to work on this one first today because I want to get that cleaned up and make sure nothing else is wrong with this. And we'll come to this one if things go very, very smoothly. So I've also got this is a new toy. It's under testing. It's a Yahoo 948 desoldering station. I'm going to turn it on right now, actually, because it takes a while to warm up. But I'm going to be using this to remove the ROM from this board today, but let's get that out first. Actually, before that, I need to actually demonstrate the problem. So a blue screen with no BASIC coming up is a classic BASIC ROM problem. But what really came through for me was DesTest switch. I believe it was on this one. And if I run DesTest switch, which I'm pretty sure it passes all of the RAM and everything, so it doesn't have a problem there. But we'll just quickly skip through this bit until we get to the switch part of the test. And in this part, it tests the ROMs and it shows the checksums there of the ROMs, and it's showing that the BASIC ROM is bad, or is not, it's failing the checksum at least. Could be something else wrong. I think just taking this off for now is a good idea. Get out of my way. Splattered solder all up the inside of the case there. Right, let's get this out of the case. Missing a few screws in this one. One here, and one here. Ah, this has had work done. This is quite interesting. Yeah, this here, you can see that's been worked on before. That's the colour RAM. Oh, there's another screw. That must have just been laying on the board somewhere. We're taking out this one. Got some very, very short legs on this one. Oh, desoldering station is ready. These have been cut off almost flush. This will be quite tricky to remove. I'll give it every chance. There's no moo, I'm afraid, on this one. All it does is this sound. No fan either, which is really nice. Tip is slipping off of the pins as I wiggle because there's hardly any pin sticking through, and because there's also extra bits of metal in there, I'm having to wiggle it just to get things to free up. It's not ideal, but there you go. but has done a really good job of taking out all of the solder from this side. Let's see what it's done on the other side. Yeah, that is pretty good. That is pretty good. I'm not going to risk just ripping it out. I'll try and give the legs a little wiggle first, you know, as much as I can, given how much is sticking through here. Yeah, this feels like a good pull. Take a slight risk. No, I don't want to. Oh, no, it's moving. One side is out completely. The other side might want to come out. Yeah, I'm pretty sure all of those pins are moving. The only reluctance is the ends of these pins are not in good condition. It's just snaggly and all over the place. No damage at all in there. I'll just run some braid over it just to clean it up. Put a socket in and then we'll see where we are. We need to remove the solder over here as well. Ah, stinks. Oh, I don't know what flux they used on this. It smells like beef dripping. Yeah, traditional northern flux. That'll do. Let's give that a clean. What am I doing? Perfect. Right, ROM socket. Okay, so a 226 is the ROM that we need. Well, this one's no, maybe not that one. Yeah, this one's got quite short legs, but it should be okay. These sockets are pretty good. Let's put it in the case so that it doesn't get shorted on anything on the workbench. And where does that leave us? With a working machine, of course. Let's put diagnostics on it. Okay, so that's diagnostics connected. Oh, almost. Nearly forgot the serial dongle. And we need some diagnostics. Oh, that's good. That's a great start. Just a crusty cartridge port, that's all. Looking good. Oh. Marvellous. And the only thing I need to check on this now is if the keyboard actually works. It's my keyboard, this one. Oh, it's working. Oh, spacebar is a bit reluctant. I will need to... Right, yes, spacebar is working if you press it a bit harder. So I will need to take this apart and clean the contacts for that. But that's not a problem. Spacebar needs clean. Okay, that's that one done. Just one bad ROM and everything else is working, and the edge connector restored and tested. I have got a can for this. Actually, it was just, I'm going to get some thermal grease, so I'll put that on later. So I'm going to leave that loose for now so that I remember to actually put the thermal grease on there. Now we've got this one. Oh yeah, the other thing we've got to do, as is tradition, put a big old cross on that one. All right, so this one, when you plug it in and switch it on, does a similar kind of thing. Oh no, this one is the black screen, right, yeah. But this does run Des Test Switch again. I'll skip ahead. Right, and that one's come up with bad kernel. So in almost exactly the same way, but a slightly different chip. Slightly, probably more important chip. Let's get this one out. Okay, well, we got, oh, loads of work been done on this one. That's interesting. So down here, where the RAM is, yeah, there's a timing chip down here that's been changed. There's two ROM chips here, RAM chips here, and one up here that have all been changed. This has seen some action. So we know the middle one here is the Kernal ROM. Just going to reflow all of these points and then whip this one out. One thing I don't like about this soldering iron, it will not let you pull the trigger until it's heated up, and it's got a sleep mode in it. So it's gone down to 200 degrees, and now I've got to wait for it to heat up, back up to 350 odd. I haven't got time to wait, come on. No, it's a slow heating up iron, but it does a really good job. I am quite impressed with that. Okay, so I've forgot to press record. I've put the socket in and I've cleaned up the back of the board and put a new ROM in, and this is what happens. Actually, let's do this first. Yeah, it works. But there is a problem. It passes all the RAM tests. There's nothing wrong with the RAM, but even with the test harness connected, I'm still getting the exact same fault here. U1 and U2 bad. Actually, U18 is not showing bad in the normal tests, but cassette, control, serial port, and user port are all bad. I've just taken these out and then realised that I hadn't pressed record, so I'll put all these back for your benefit. And this is the sort of thing where you're wondering, is it the board or is it my test harness? I suppose I can test that quite easily with another board. Okay. Yeah, exactly the same. U1 and U2, cassette, control, serial, and user port. And the SID's okay, which is good because they soldered it to the board. I'm not sure. I don't know. I'm going to have to look this one up, I think. First thing I want to do is try a cassette in it. But the first thing I need to do that is to find a cassette. Here's a recently repaired one. Hey, just for a minute there I thought it wasn't working. Right, it's enough of that nonsense. Cassette is working fine. So the next sensible thing to do is test the test harness with my working machine. Oh, this is not my working machine. This is a totally different machine. Oops. Right. Oh, this has got a SID kick in it, actually. Interesting. I might need to change that for a real SID, or it might throw up errors depending on how the settings are set. Let's just make sure it works first. Yeah. Yeah, I was expecting the U18 is bad. That's fine, but all of the other stuff is working. Not my test harness. There's something wrong with that machine. That is weird. Well, the edge connectors are a little bit crusty still, so I'm going to give them a proper polish. I think it was this. Seeing how much crud is coming off of this. And I thought I cleaned it. Let's give that another go. I'm mostly spraying that in there for lubrication, so because this is a super tight edge connector socket. And it's really difficult to get off. So it's just going to help me do that. Try again. Those two. Oh, still bad. All this time that this LED has been not working properly on this edge connector, on this test card, I didn't realise I just hadn't soldered one of the pins on the LED. That works better now. Right, so I'm going to have to do some investigating on this now. Should be a fun one. Okay, it's the next day. I haven't had a lot of time between the last time you saw me, which was moments ago, and now, but I think I've come across something quite quickly, and what I found was this. I'll show you on the faulty board. Now, pin 23 is chip select. 21, 22, 23. Now, that's not right. If I show you the chip select on the chip next to it, this is on U2. 1, 2, 3. That's what it should look like, kind of, but I'm going to show you, this is a working board, which is over here, but just trust me, it's the same pins that I'm going to be scoping. So pin 23 on U2, 1, 2, 3. Should occasionally show a bit of activity, but not constantly. 1, 2, 3. This is U1. So U1 matches up. That chip select is always there. It's always being monitored. I think that's it's polling for the keyboard basically. So 1, 2, 3. So that's the same. U1 pin 23 is the same. U2 pin 23 is like this, and it shouldn't be like that. It shouldn't. I mean, it looks like it's ghosting the other line. Now, These are, I've got a terrible printout here, but I'll put it up on the screen. And basically U15 is an 74LS139. And the chip select lines, this is something that Mark pointed out in a previous video, in the big collaboration video that we did with Adrian as well. And Mark pointed out that some of the chips, well, we were talking about the chip selects for the VIC, the SID and the colour, and it also does the CIAs. So I need to interrupt Parsley here. This is Editing Lee. He's just got up from his editing desk to come and put some stuff right. So the bit that I've cut out of this video, which patrons got to see, was my explanation of how the circuit, or how the chip at U15 works to create the chip select lines for the VIC, the SID, the colour RAM and the two CIAs. And I completely butchered it. I absolutely didn't understand the circuit at all, which is testament to the fact that I don't understand these things, and very often I just have to learn as I go along. And sometimes I make assumptions that are not ideal, but this is the nature of this thing. I've never claimed to be an expert, and I don't think I ever will. And I just hope that everybody understands that. But new people are joining all the time, so it's quite difficult to get that message across without constant reminders. But I'm here today to give you an explanation I believe is correct. So here we have the relevant part of the circuit with the PLA over here at U17, and it's connected to this blue line here is all of the address lines. And rather than showing all of the address lines individually like down here, they kind of bunch them all together and then just assume that A9 connects to A9 wherever it goes. So A9 is down here, but it's also over here and here. So the blue line just connects these things, and that's fine. Let's zoom in on U15 a bit more. So this is U15 here, and all of this is U15. This is one half of it. This is the A half of U15, and this is the B half of U15. And the A half of U15 controls the chip select lines for the VIC, the SID, and the colour RAM, but also the CIAs. But there are two CIAs, and the other half of U15 controls which CIA is selected when one of the CIAs is required. Now, there's a truth table on the A side, which is governed by A11, address line 11 and address line 10, and depending whether these are high or low, it depends which one of these is selected. So these are all active low, as designated by this line being at high. I've never really got my head around that, but it confuses the hell out of me. So if these are active low, then for instance, if both of the address lines are high, as in 00, 0, I think that's right. I'm still trying to get my head around this. Then the VIC chip is selected. There are 4 different combinations that govern which one of these is selected. And if both of them are active low, so address 11 and address 10 are low, then this select line is activated and goes low. Now, if that goes low, then this chip is then switched on, and it's now going to look at address line 9 and address line 8. And similarly, it looks at the address lines 8 and 9 to determine which CIA line is selected. So that's how these two halves of the chip work together. I've learned a lot. Thank you to Life Size Teddy Bear for helping me understand my confusion by pointing out my mistakes. It really is genuinely useful, and long may it continue. On with the show. To pin 13 and 14, and then the actual chip enable lines for CIA2 and CIA1 are pins 11 and 12. So for CIA2, which is U2, we're looking at pin 11 over here on U15. And it's not really going to tell us much because this is just a direct connection. This is going to show exactly the same thing. So what did we say? Pin 11. Right, so this is pin 11. shows that burst of activity, and then this weird, if I zoom in on that a little bit, that should be a square. It should be a square wave, but it's not. It's just a point. Something's wrong there. Whether it's U2 that's causing the problem or U15 is something I'm not sure about at the moment, but I've got a way to find out. So if it's U15, then that signal that we're seeing should be available on this pin if it's disconnected from the circuit. So I'm going to desolder that pin 11 from U15 on its own. I'm going to isolate it from the wire around it and then test it just on its own without it touching the rest of the circuit. If it can, I could do the same with pin 23 of U2. I might do both. There's an idea. Let's do both. I'm going to do both. Didn't expect that, did you? And I'm going to use the annoyingly slow Yahua 948. It's very, very slow. This would be a great desoldering station if it heated up quicker. I'll come back. I'm going to have a drink. Tasty. One problem I've got going on here is that all of the legs on all of the chips on this board are hooked like I've not seen before. They are really, really rank. That's taking so much solder. I think it'd probably be a good idea to take that off this side. This is going to make the hook, it's going to make separating the pin from the wire quite tricky. I'm going to give it a go. It's a neat way. This is what I like to call my Happy Little Diodes method. Jim from Happy Little Diodes YouTube channel, who I often mention and recommend to other people. He first mentioned this on his channel and I thought it was just such a neat way of doing it. The other alternative, of course, is snipping the leg. Don't like doing that. This is a bit more hassle. It's not that difficult, and you end up with a complete intact chip that you don't have to solder legs back onto, which is always a faff. But we all do things our different ways. You know, nobody says there's a set of rules that you have to follow in this hobby. Well, some people think there is, but there isn't. Right, that's warmed up. Excellent. It's very good. Okay. That pin is just already floating in the hole. That's good. And so is that one. This is really good. Now the difficult thing is if this side, if the chip has been really shoved into the board while it was being manufactured, this is going to be difficult, possibly impossible. Possibly impossible. Right. Still connected there. Still connected there. Okay. The U2 pin 23 is now disconnected. I haven't disconnected this one though. Let's see if I can manipulate this a bit more. Might be able to do it from the top. Oh yeah, there's a bit of solder still there. I don't know if this is going to be possible to disconnect this one. Probably would have been easier just to take the chip out. I can't get it free from that end, so I'm gonna actually resolder this end. Got it disconnected to the other end. That's all I really need. Now, if I check between that pin and the end of this one, that should be okay. Go this way. 15. Yeah, there's nothing. Ah! Reconnected it just by pressing on it. I think that's got it. Yep. Right. Now I'm actually going to measure over at U15 because if I press over here, I'm probably going to reconnect it. So let's try probing here. It's the same. It is the same. There should be nothing there now. Out of interest, what does that do to on the display? We just get a black screen now. So I think it's U15. Apparently these don't go wrong very often, but let me just solder that point back up to make sure this is still working. On U23, because I don't think it's that. Right, so no chip select line on U23, and you get a black screen. That's interesting to know. U15 needs to come out then. Excellent, that's out. I've got this chip tester that I've shown in a video recently about fake chips, and it should just tell me if this is a working chip. '74LS139, so don't think it's going to be this. Probably was always more likely to be U2, which is a real shame. But because this is now going to be socketed, I'm going to put a different LS139 in there just in case this has got some slightly weak output drivers. Yeah, I think that's the thing to do here. So 16-pin socket. Going to keep the soldering iron hot and take out U2 as well. Right, popping on a nice new LS139 in there. Same thing happening there. Let's just check that output. Yeah, same thing. So I think the thing to do here is to take out U2. It's definitely getting selected when it shouldn't be. All right, don't let me forget to put that 139 back in. I don't need to leave a brand new chip in here when there's nothing wrong with the original. Well, that is pretty incredible. That chip is just falling out of the board. That I've not don't often see that. Test machine with diagnostic cartridge. Set to no RAM check, I think. Right, so we get the same thing. Do you know what I think I'm going to do instead? Rather than connecting up the test harness to this one and then the other one as well, is I'm just going to put a good chip in the other one and test that with the test harness. Socket, I need a socket. Just switching this on is not going to tell us much, apart from that it is currently working. And this shouldn't tell us much either. Now we need to check the test harness, or check with the test harness. Oh, I've got the keyboard connector on the wrong way round. Okay. So with that chip in there, it's now a fully working machine. So it's definitely this CIA. So I want to put that 139 chip back in, but I can't find it. Here it is. Right, yep. So definitely not the 139, was definitely the CIA. So I'm going to have to find a CIA for this one. They are probably one of the chips I need the most. Actually, I did buy some from... Where did I buy them from? I bought a couple from the Museum of Computing History Jumble Sale, 6526. Here they are. I've not tested these, so this is going to be a good test. I've got my new chip puller. So good. These look like either out of socket or new old stock. 1984. And perfect. Brilliant. Right, I think that's enough for this one. The only thing I really need to do is check that this keyboard is working, clean the spacebar on the other one, and button these up. They are done. That was a bit more interesting than just a couple of ROM swaps, so yeah, I'm quite pleased with our work today. Well done, everybody. And wow, I don't think I made any stupid mistakes, did I? No. Maybe. I don't know, maybe starting to repair these things in the first place. Anyway, if you've not subscribed, maybe consider subscribing to this and More Fun Making It as well. And if you want to support the channel, go and have a look at Patreon. There's a link in the description. There's a lot of stuff that I put on there, early access and exclusive content and updates and all kinds of things. For the free tier of Patreon as well, they often get update videos and a few extras along the way just to build up a community there. It's a nice thing. But yeah, the support I'm getting on Patreon from other people that are on the pay tiers is phenomenal, and one of the reasons that I can make these videos. Paul is another big reason I can make these videos. Thanks, Paul, for sending me another batch of these things. Excellent. Right, I'll see you in the next one. Goodbye.